everyone, welcome to Universal Light. Today we'll be studying computer science for O level and IGCSE, and the reference book that we are going to be using is from Cambridge, that is of Hooder Education, and this has been referred to us as Cambridge. This book has been designed for IGCSE and O level appearing students for computer science second edition. This book is really nice, and I would suggest all the computer science O level and IGCSE students to refer to this book for examples, for questions, for explanation. Okay, so the chapter that we are discussing today is chapter 10 from Boolean, chapter 10 from this book, which is the last chapter, and the name of the chapter is Boolean logic, which most of the students consider to be very difficult. And today we are going to be discussing in great detail, and a lot of content is going to be covered, which is probably going to solve all the queries related to this chapter, and you'll find it really easy and interesting. Before we continue, I would request all of you to please like, share and subscribe, and if you have any questions related to anything after this video, please do leave them in the comments, and I will try my level best to resolve all of those questions there and then. Starting off, firstly we have to discuss the inputs for Boolean logic. Most commonly the inputs that we receive are 2 or 3, and it's a really rare case when you receive 4 inputs. So we are not really going to look at those examples, because till now whatever past paper questions that I have solved, I have never encountered any such question with 4 inputs. A, and B. This is just an example that I'm discussing. Not really an example, these inputs are given to us in the questions that we solve. For A we have 2 zeros and 2 ones. For B we have 0, 1, 0 and 1. Just in case you receive 3 inputs, A, B, and the third input is C. These are the values that you will be getting. 4 zeros and 4 ones for A, 00, 11, 00, 11 for B, and 01, 01. Now it's not necessary that you'll be getting every time the inputs like these values with the names A, B and C. You might get it as P, Q and R. We will see those types of questions when we are solving it, and you will be able to understand what I'm trying to say right now. These inputs are usually given to us in the examination paper, so it's not really necessary that you have to learn all of them by heart. However, as you'll be solving the questions, you will eventually learn it. Let's continue. First thing we have discussed is the inputs. The second thing that we are going to be discussing is the logic gates. Let's just label these logic gates with numbers, and then we are going to be discussing its operation, its function, and at the end we are also going to be discussing some past paper questions, just so that you can learn the pattern and you can have the idea of the types of questions that you'll be getting. I'll also attach in the video the reference from where I have taken the past paper and all, but let's just reach to that point. Till then, first let's learn the logic gates and its expressions. Okay, let's start off. The first gate that we have is the AND gate. When you have the AND gate, you have to multiply two inputs. For example, A multiplied by b. The symbol for AND gate is this, like the gate that you have to draw basically, and the multiplication sign is denoted with a dot. This means to multiply. I will also give you some examples for it. For example, you are given two inputs A and B, 0, sorry, and you have to multiply them. So output for it would be 0 multiplied by 0 is 0, 0 multiplied by 1 is 0, 0 multiplied by 1 is 0, 1 multiplied by 1 is 1. So this is basically the output that you will get from it. Okay, I hope that's clear. Let's move on. Okay, the next logic gate that we are going to be discussing is the NAND gate. Why am I discussing the NAND gate? Because it's just the inverse of AND gate. Okay, so this and this is connected, and this is connected. How is it connected? You will see that. Okay, the second gate that we are discussing here is the NAND gate. In this you have to multiply, and then the multiplied value will be inversed. This dash that we are drawing on top denotes the inverse function. Okay, third gate we are discussing is the OR gate. You will add two inputs in the OR gate. For example, 0 A 1. Okay, next gate, the inverse of OR gate is the NOR gate. You get A plus B, the value of A plus B, and then you inverse it. This again means inverse function. The fifth gate we are discussing is the NOT gate. The NOT gate has only one input. If you see these dash that you see over here, these denote that how many inputs this basically has. So NOT gate only has one input. This is the only logic gate out of all the ones that we are studying here which has only one input. In this you just simply have to inverse the value. You can inverse A, maybe B, maybe C, whatever value it is given to you, you will just inverse that. For example, if 0 was given to you, you will turn it into 1. If 1 was given to you, you will turn it into 0. Clear? The last but not the least gate that we have is the XOR gate. Now there's a proper explanation for XOR gate. Okay, for XOR gate, when you have two same inputs, okay, so we have two different points for XOR gate. Two same inputs will have the output 0. Two different inputs will have the output 1. I'll show you how it happens. See, you are given with the values. I'll be drawing it here because I don't really have much space. A and B. Zero and 1. For example, 00. Okay. In this situation, you see where we are having two same inputs. You will be getting the output 0. You'll be getting the output 0. When you have a different input, you will be getting the output 1. This is the explanation for XOR gate. I guess the logic gates should be all clear to you. I'll just repeat it, whatever I have discussed throughout. The first gate is the AND gate. In AND gate, you have to multiply the two inputs A and B. In the NAND gate, it is the inverse of AND gate. You will multiply the values of A and B. That is, you will first be applying the AND gate, and then this n means that you will inverse the value. For example, if A multiplied by B, you are getting the value 0. For NAND gate, if you are applying the NAND gate, you will inverse that value. If it's 0, it will become 1. If it's 1, it will become 0. Clear? Then the third gate that we have is the OR gate. In OR gate, you have to add the two inputs A and B. In the NOR gate, you have to add the two inputs and then inverse the value that you received, similar to that of the NAND gate. In the NOT gate, you will simply inverse the input. For example, you have the input 0, you will inverse it to 1. If you have the input 1, you will inverse it to 0. Okay? The opposite has to be written in it, whether it's A, B, C, whatever inputs that are given to you. A NOT gate has something really special to it, you can say, is that it has only one input. And if you see the trend in the other logic gates, they all have two inputs. Okay, the last but not the least gate is the XOR gate. In the XOR gate, two same inputs will have the output 0, while two different inputs will have the output 1. And you can see the explanation here. 1 and 1 will give you 0, 0 and 0 will give you 0. 1 and 0 will give you 1, 0 and 1 will give you 1. Okay, I hope this explanation is clear. Now we'll be looking at some examples from the book and some examples I will give you, and this is how we'll be solving and understanding it. Okay, so the book that I'll be using for the examples is this, and the first question that I'll be taking from here is from activity 10.1, and I'll be writing the reference here. If you have the same book, this will be your reference for it. Activity 10.1, page 359. Okay, so the first question that we have is show y. Okay, when a question that is given to you says show y, in show y you have to probably or mainly you have to draw the logic circuit. Okay, the statement says x is equals to a and not b, or not a and b. We are aware of the logic gates, and this is how we'll be drawing the logic circuit here. A and B, these are the two inputs that we have, A, B. Right, now what do we have to do? Take one line from A and take one line from B. Sorry. Now at this point we can see that it is saying not B. Okay, it's not simply A like here. Oh, sorry, B. It's not B. Not B means you have to draw the not gate here. Let's draw it. You have taken a line. Okay, here you will draw the not gate. Drawn exactly how it has been made above. Okay, then these two logic gates will be joined together with the AND gate. Okay. Now always remember, this OR gate, any gate which has been given in between two brackets, is always the last product. Okay. Now they are saying not A and B. Here we see that A is being inversed, right? Isn't it? And B is the normal B that we have. You will take a junction from here and you will extend a line. Okay. Draw the NOT gate for A. Then you'll take a junction from B and you'll extend it downwards. Then these two gates will be joined together by the AND gate. Why are we joining with the AND gate? Because this is the gate that is given to us in between. Okay, so join it by AND gate. Okay, now comes the part of the OR gate, that is the final product. You will take these two gates. Okay, and the final output you're going to produce is this, and this will show your output X. So what have we practiced here? We have practiced here a logic circuit. From this logic circuit we are going to be drawing the truth table, and that is the last thing for today, for this video, which is part 1 of discussing Boolean logic. In part 2 we are going to be discussing further ahead of this, and let's just first draw the truth table. Okay. So what are we drawing here? We are drawing the truth table here. Firstly, let's see the logic circuit. It's totally up to you if you want to draw the truth table from the expression, that is A is equals to A and not B, or not A and B, or you want to draw it from the circuit. Okay, so here I have just copy pasted the entire logic circuit and the expression. Okay, let me tell you, this thing is called expression, logic expression, and this whole thing is called a circuit, and the thing we are drawing is called the truth table. Okay, firstly we have 4 inputs here, A and B. Okay, this thing is usually given to us. Okay, these inputs are usually given to us. A and B. The first thing this says is the AND gate, and here NOT gate. A and not B. A and not B means that A will be multiplied by the inverse of B. Not B is inverse of B, right? Here we studied that. Here we studied that it is always the inverse, right? So doing the inverse of b means you'll write all the values oppositely. Okay, now and means you will multiply, and not means inverse. So a multiply by not b. Let's multiply these two. 0 ones are 0. Oh, sorry, we don't have to do this. Sorry, this and this. 0 and 1 will give you what? 0. 0 0 0. 1 multiplied by 1 is 1. 1 multiplied by 0 is 0. Okay, now this thing is done here. This gate is done. Now okay, this thing has to be left for the last. Okay, you will do this at the end. Now not a means the inverse of a. Double 1 double 0. It says not a means the inverse of a, and means multiply by b. We will multiply b with not a. Okay, let's multiply it. The pink ones. 0 multiplied by 1 will give you what? 0. 1 multiplied by 1 is 1. 0 and 0. Now the last gate that we have is the OR gate. When we have such types of questions, what we have to do is the main gates, okay, this and this, we'll label it as P and Q. We have to give them a name, P and Q. Okay, now OR means you have to add P and you have to add Q, because instead of writing the whole equation, this is easier, right? You denote it with a simple letter, P plus Q. We'll be multiplying this with this. Okay, we'll be adding it. 0 plus 0 is 0, 0 plus 1 is 1, 1 plus 0 is 0, and this will be your final output, that is output x. X is equals to 0 1 1 0. I hope this entire concept of inputs, starting with the inputs, then the logic gates, logic circuit, and this truth table, I hope is all clear to you all, and you'll be having no confusion with that. However, if you do have any confusion with it, please do leave it in the comment section, and I'll try my level best to solve all your problems related to it. That was it about today's video, and this video particularly. This was part 1 of chapter 10 Boolean logic. Don't forget to like, comment and subscribe to our channel. In part 2 we'll be discussing further ahead and questions from activity 10.2. The last part, I guess, is going to be part 5, in which we'll be discussing some past paper questions. Till then, take care of yourself, learn this, practice it, and let's meet in another video with a new hope and determination. Thank you for watching. Take care of yourselves. Bye.